Okay, so the first announcement that I want to make today is as follows. We have gone through unit 1, we've gone through unit 2, we've gone through unit 3. Holy smokes, we have, as of yesterday, completed unit 4 as well. Okay, so all of these homeworks, 12, 13, 14, with the various extensions, etc., they were all due last night by midnight. Yesterday, we completed lesson 15 in class, and therefore the due date is next week on Tuesday. Okay. So the cool thing is as follows. We have one more unit left. That's it. Now, one of the things that I'll tell you all is that within this unit, there's 2 lessons, lesson 16 and then lesson 17. Instead of having 2 separate homework assignments, I just have one homework assignment. Okay, so you currently have one online homework assignment that's been assigned and is due next Tuesday. And then when we finish this online homework assignment, that'll be the last one. Isn't that cool? Okay, other thing. I am going to, for class on Friday, I'll print out the last worksheets and bring them to class on Friday. I've made them and, you know, I just haven't made copies yet. And I will also be making that active on the class Moodle page. Okay, so that'll be this Friday, and probably what I'll do is just have it be due the last day of class. Just why not? Okay. Now, what I plan to do in terms of the class at this point, again, I just want to first let you know what we still have open. So you still have a couple homework assignments and a couple worksheets. And we do have the last test that occurs during finals week. I don't have my syllabus in front of me. I don't control when our last test is. That is done by the registrar's office. But I believe that we have our last test the last day of finals week. I think it's at like 8 o'clock in the morning. So kind of a lame time for sure, but it gives you the entire week to study. So I guess that's a positive, right? Anyway, I'll talk more about that last test next week. We will have time for at least 1, maybe even 2 days of review beforehand. But even though the final exam is a 2-hour time block, I'm happy to give you the full 2 hours to take it. But having said that, I only wrote it. I've already written it. And I wrote it to take an hour, just like the other tests. So time should not be a factor at all. You're welcome to take as much time as you need, because honestly, all I have left to do that day is grade, amongst other things. But anyway, I feel like we're in really good shape entering our last bit of material. Okay, what I want you all to do is as follows. Lesson 15, again, we finished yesterday. I want you all to get going on that sooner rather than later. Okay, and I'm happy on Friday when we come in to class to start class by answering any and all questions you have on lesson 15. Okay, so I encourage you all to get moving through that. I realize you have other classes and you have a lot going on. I mean, this is sort of a, well, not sort of, this is just a crazy time of the semester for everybody. So please know that I feel it with you. And I'm happy to do whatever I can to help you all through this. But what I want to say is I'm going to talk about Unit 5 today. I don't go in order, lesson 16 and lesson 17. So bear with me going through it. Again, there's certain things that we just plain don't need to do in this class because we have the technology that does it. So I really want to just meet the learning outcomes of this class and not overwhelm you with details that you just plain don't need. Okay, but next week, I assure you, I will talk about the last test and also just about how grades are computed and everything else. It's in the syllabus, and I did talk about it on day 1, but day 1 seems like many moons ago. And in fact, it was. So just to give everybody, you know, like a re-up so that nothing comes as a surprise to anybody. Sound good? Awesome. Awesome. All right. Anyone have anything fun to share with us before we start math? No? Well, it's the last day of November. Isn't that wild? It is crazy. It is like time flies and then it drags. Not necessarily when you want it to in either of those cases. Anyhow, if you weren't in class yesterday, the one thing that I will say is you will want to access the video because in class, I showed how to do the calculator portion of lesson 15. I showed it on both the TI 8384 calculator as well as the TI 36. So please be sure you access that to get instructions on how to use it. Okay. Are you all sad that you're almost done with your math class? Yeah? Are you relieved? No? So one of the things that I'll tell you all is I'm always happy to help you in your future math classes. Like I would be of absolutely no use to you in a lot of classes that you take, but I can help you in your math classes. So yeah, don't. Sorry. Okay. And statistics is fun. And whether you're taking it here at Missoula College with Scott, he's awesome. He's so great. When I came here to start my position over here from the university, I brought him. So he's wonderful. And those of you who take stats over on the Mountain campus, Fred Peck is the person who teaches that, and he is amazing also. So right now is the time to take stats because you can't go wrong with your instructors. Seriously. So, okay, ready? Unit 5, so this is lesson 16 and 17, is on something that we call linear programming. And there's a lot that you're going to see. Those of you who watch the videos attached to My Open Math, those of you who read through the textbooks, you're going to see a lot in here that we just plain will not be going through. Again, I only test you on what we do in class and things similar to that. Okay. What I claim is what we're doing here, at least our starting point, is really going to seem like more of the same as what we did in lesson 15. Okay. There's just going to be one slight difference, and it's going to bring us back to something that we thought about in the statistics part, but don't worry, or whatever, there's no statistics. Okay. So, you know, we were solving those systems of equations. So for example, we had that thing with like, we wanted to make transistors, resistors, and computer chips. Okay, and we wanted to know, given the amount of materials that we had, how many of each we could make. Okay, it's a very logical thing to do, right? Because you want to use all of your materials. You want to be as efficient as you can with things, but you also want to maximize your productivity. Okay, so when we were looking at those before in lesson 15, we always solved these inequalities, and life worked out really quite perfectly. And as we know, in general, in life, things don't work out perfectly. You know, sometimes you might have a certain amount of, what do we need? Copper, zinc, and glass. You know, maybe we won't be able to use all of the copper. We might have some left over given, you know, how many things we can use. So what we're trying to do here is just be more realistic with things, okay? In other words, instead of things being just always equal, sometimes we have to be satisfied with, well, we have, you know, 785 units of copper. Okay, that's the maximum we can use. So it might be more realistic to say less than or equal to 785 units. Okay, so what I want you to do is just recall when we were talking about less than or equal to, that's at most some number, and greater than or equal to corresponds to at least some number. This is the memory thing back to when we were doing some probability and statistics. Okay. So what I'm going to do is I'm going to tell you that these word problems essentially involve us setting up a system. They involve us defining our variables, but there's one extra step, and this is where capitalism comes in. Okay. So I'm just going to show you with an example at the start. So suppose I tell you that a company makes 2 types of TV sets. The Ultra sells for a $350 profit. So, and the other kind we'll call the Supra sells for $500 profit. Okay. Furthermore, on the assembly line, the Ultra takes 5 hours to build, and the Supra takes 7 hours to build. The cabinet shop spends 1 hour on the Ultra and 2 hours on the Supra. And finally, the testing and packing department spends 4 hours on each. So suppose the company has at most 3,600 hours in the assembly department, at most 900 hours in the cabinet shop, and at most 2,600 hours in the testing and packing. We want to know how many of each type of TV should they make to maximize their profits and worker hours. A lot of writing. I'll give you a second to let me know when you're ready. So you'll see that there's a lot here, but what I want to do is I want to talk about this scenario and break it down. Okay. Y'all got it? Okay. So what do we have here? Oh, okay. Thanks, Haley. Tell me when you're ready. Cool. Thank you for speaking out. I mean that, Haley. All right. So what we have here is we've got this company that makes television sets. Okay. It's the goal of most companies to maximize their profits, correct? You maximize your profits. That means you get to bring more money home to you, and your employees also get to bring more money home. Okay, so clearly maximizing a profit is something that we wish to do in our society. Okay, now, obviously one could say, well, listen, the way to maximize profit is to make as many TV sets as possible and sell them all. And given the fact that we get a $500 profit from the Supra, it might make more sense to make more Supras, right? Okay. The thing is, as with everything else in life, we have limitations or constraints, right? You can't just make a ton of TV sets. In this case, we're limited by the number of worker hours we have, okay? We're limited by the number of worker hours we have in each of these three departments. So essentially, given the fact that while we make more profit off the Supra, it takes more time in a couple of these departments. So at what point do our worker hours balance off with the profit? So what we essentially want to know is, given these constraints that we have with how many worker hours are available, how many of each should we make in order to maximize our profit? Okay, so what's the new thing here? That we have a goal. Okay, we actually have a goal to maximize something. But we're going to start out the exact same way we started out in the previous lesson. So at this point, nothing should seem very different. Okay, the first thing that we'll do, and the first thing that I'll have you do on your test, is define your variables. Okay, does anyone remember the hint of how you define your variables? You go to the question that is being asked. What are we looking for? Good job. Okay, so let's go to the question. How many of each type of TV should they make? Cool. I'm going to let X represent the number of Ultra TVs, and I'm going to let Y represent the number of Supra TVs. Now notice I don't say X is ultra, Y is supra. These represent a quantity. And that's a very important distinction. Okay. Any questions this far? Okay, here's one added step. We want to state our objective and then give our objective function. This is new. Okay. Well, what is our objective? Well, we want to know how many of each type of TV they should make in order to what? Maximize our profits, right? So in this case, our objective is to maximize our profit. In general, my friends, my hints to you are as follows. Remember to define your variables. You go to the question that's being asked. To state your objective, continue reading the question that is being asked. Okay, you only have to write 2 words here. We're either going to be maximizing things like profits, or we're also going to want to be minimizing things like costs. But you'll always be told what it is you want to do. And now what we need to do is we need to write out what our objective function is. So notice our objective is to maximize profits. So my objective function is going to involve how much profit I'm going to make. Okay. Well, how much profit do I make for each ultra set? $350. So would you grant me that the total amount of profit that I'm going to make for these ultra sets are $350 per set times the number of sets? And then similarly, we're going to get $500 profit for each supra set. So our total profit there will be $500 per set times the number of sets. We tend to use the letter Z for our objective function. You can call it anything you want. You can call it P if you want because it's profit. But it's going to be 350 per ultra set times the number of ultra sets plus 500 per supra set times the number of supersets. Again, how did I know that this would be my function? It corresponds to whatever your objective is. Okay, in this case, our objective was to deal with profits, so we had to go to our profits. So what does this function give us? Well, do you agree then if we solve whatever system we're going to be setting up and we find our value of X and we find our value of Y, we can then figure out what our profit's going to be? Okay. Now, part C prior, well, the next part prior was to set up our system. The way we usually talk about this is give the constraints or limitations. And just like when you set up your system, you would look at totals, you're going to look at totals here again. Again, you might say, well, listen, in order to maximize profit, let's make a ton of these and a ton more of those. Okay. But again, we're limited by things. Okay. So now we've got to talk about our barriers or our limitations. Okay. Now, when I say look at totals, notice we're given how long each set takes on the assembly line, the cabinet shop, as well as testing and packing. But look, these are the total hours that we have available. So I know to go to my totals, and I'm going to have this 3,600 from the assembly department. I'm going to have 900 from my cabinet shop and 2,600 from my testing and packing. But notice though, we say it most. Obviously, if we can get equality, then we're making the maximum use of our resources. But the difference here is now you have inequalities. And now let's talk about the time each of these take in each department. So let's talk about the assembly line. The Ultra takes 5 hours per set, and the Supra takes 7 hours per set. So how would I write that total amount of hours on my left-hand side? You are awesome. 5x plus 7y. And again, ideally, we would just say equals 3,600, but we can't always count on that perfection. Let's talk about the cabinet shop. How much time do we spend there? 1x plus 2y. And finally, the testing and packing. 4x plus 4y. Now I claim I'm not quite done, but I need to ask if there's any questions this far. So thus far, what are the differences? We actually have an objective and an objective function, okay? Our objective will always be maximize something or minimize something. That's where the capitalism comes in. And the other thing is we don't expect perfection. We're realistic that we probably won't get to make enough sets that we have equality everywhere, but let's do the best we can. Now, there is one other set of inequalities that you need to have, which will make sense when we get to the next portion of this. The other set of inequalities you need are that x and y have got to be greater than or equal to 0. You'll see why that's important when we actually talk about how we would solve a system of inequalities. Okay, but essentially what we're saying here is, well, if x represents the number of ultra sets and y represents the number of supersets, we can have 0 or more. You can't have a negative number of sets. In other words, it might turn out that we maximize our profits if we only make one of these types of sets and not the others. Okay, so this greater than or equal to 0 just tells us you can't have a negative number of sets. Okay, this is the one thing, like, you know, you get a little sheet of paper with notes, you're going to want to write that down so you don't forget to put it. All right. So what I would like to do now is just set up one more example for today. Okay. I wanted to start out by setting these things up because that really goes in conjunction with exactly what we've been doing in lesson 15 with some minor tweaks. You ready? Are you thrilled? Cool. Okay. So let's pretend that we have a dietitian and that dietitian is making a snack package. From fruit and nuts. Suppose I tell you that each ounce of fruit supplies 20 calories, 0 units of protein, 2 units of carbs, and 1 unit of fat. Furthermore, suppose each ounce of nuts supplies 30 calories, 3 units of protein, 1 unit of carbs, and 2 units of fat. All right. Each snack package boy, my handwriting is just getting terrible. It must be the end of the semester. Must have at least 6 units of protein, at least 10 units of carbs, and at most 9 units of fat. And what we want to know is how many ounces of each should be used to meet the requirements with the minimum number of calories. Let me know when you have this written down. You ready? Those of you online, are you ready or not yet? Thank you for replying, Riley. All right. So what do we have here? We're making a snack mix. And what we are going to put in this snack mix is fruit and nuts. And each ounce of fruit and nuts contains a certain number of calories, protein, carbs, and fat. And we want to meet these requirements with each snack package. Okay, so in this case, what we want to know is how much of the fruit should we use and how much of the nuts should we use to meet these requirements with the minimum number of calories. Okay, so part A should come as no surprise. Define your variables. What is it that we're looking for here? The amount of fruit and nuts we need. Again, go to the question that's being asked. How many ounces of each should be used? Are you seeing the pattern here? Cool. And I claim, that this is going to help you moving forward in general anyway, because, I think what we're working on here is just a critical thing of translating English into math, which is an important skill to have. Okay, so X is the number of ounces of fruit. And again, you can call these anything you want. I always use X and Y because I have no originality in them. All right, next thing. We want to state our objective and give our objective function. Remember, your objective literally only needs to be 2 words long. You want to minimize something or maximize something. What is it here? Well, remember, continue reading the question. Yeah, we want to minimize the calories. So do you all agree that our objective function then is going to be pertaining to the calories? Okay, so let's go. How many calories does each ounce of fruit supply? 20. So what would be the total calories? 20x. And how about my nuts? Plus 30y. All right. Finally, last thing for today is we want to give the constraints or our limitations. Well, what are we limited by here? Again, just like when we would set up the equation, we're always limited by our totals, okay? And or requirements. And in this case, we want a certain amount of protein, carbs, and fat. Okay. So let's first talk about protein. How much protein does each ounce of fruit give us? Nothing. So for my protein, we could put 0x. We could also ignore it. How much protein do our nuts give us? Plus 3y. And notice we want at least 6 units of protein. At least means greater than or equal to 6. Right? At least means 6 or more. Now let's talk about our carbs. We want at least 10 units of carbs. Well, how many carbs do each supply us with? 2 and then 1. So wouldn't that be 2x plus 1y? And we want at least 10 units of carbs. So that will also be greater than or equal. Finally, let's talk about fat. Okay. How much fat does our fruit and our nuts give us? Isn't it 1 unit for fruit? So 1x and 2 units from our nuts. So plus 2y. And we want at most 9 units. What does it most tell us? Doesn't that tell us 9 or less? So less than or equal to 9. Notice at least means greater than or equal to. At most means less than or equal to. And then, of course, we can't have a negative number of ounces of fruit and nuts. Are there questions on setting these up? Awesome. Well, I think this is a good place to leave off for today. A, because there's only 4 minutes left. And B, because then we have to start getting into how to solve these. So Riley, that's an awesome question. We haven't talked yet about how we solve these. At this point, all we're doing is we're setting them up. All right, so I hope you all have an awesome day today. I hope you all have an awesome day tomorrow. It's the one day we don't have class each week. And I shall see you on Friday. And anyone who's handed anything into me physically, I have all the papers here if you want things back. I sure love to hand them back. So thanks, everyone.